Welcome back, you cool polar bears and polar cubs. Let's talk about Chapter 2, Section 4, converting tons of units. Now, tons of units can be squared, it can be cubed, it could be multiple units in the numerator and denominator. It just depends on what they give you. So, the first question that they give us is something that's squared. So, it's squared, so you got to do everything twice. Anything you do twice. So, for example, we're going to do 7.48 times 10 to the 0, and that would be megagrams squared over 1. So when we set up our factors like we have in the past, we're going to have to set up 2 of them. Each one is going to have megagrams at the bottom. And at top, we need nanograms. Okay. So now we're going to look on our periodic table. And on the back, in our metric line, we're going to see which one is furthest to the top. That's going to be mega. That's going to get our 1 both times. Nano is going to get our 10. And now we need to look at steps. Now, keep in mind the prefixes on the back do not have 10 to the 0, so keep an eye on it. What I like to do is I like to find mega, which is 10 to the 6th, and I like to find nano, which is 10 to the negative 9th. And I like to think, hey, what's the difference between those two? Well, 6 and negative 9, that's 15. So each of these is going to get 15. When we multiply the tops, look at this. 1, boom. That's squared, boom. And we got nanograms squared. So when we multiply it, our final answer is going to be 7.48 times 10 to the 30th nanograms squared. So that's not terrible. It's just adding one more step. Let's try another one. That's just telling us kind of how we want to make sure that our final answers are put together. So this one's cubed. Now, I'm going to show you this one in 2 ways because I want you to understand that they're not always going to be metric to metric, that sometimes it might be English to metric. Okay. So the first way that I'm going to show you is the metric way. This is how I would actually perform this problem. So we put this in scientific notation. Since it's cubed, we need those factors 3 times. Centimeters is going to go down on the bottom. Meters goes up top. The bigger one is meters, so that's going to get the 1. And within a meter, there is 10 to the 2nd centimeters. Remember, meters is the base unit, so it would be 10 to the 0 on your line. So from 10 to the 0 to 10 to the negative 2nd, which is centi, there would be 2. 1, 2, and 3. So we're going to be in meters cubed. When you divide with exponents, you subtract. So this is really 2 minus 2 minus 2 minus 2, which gives us a final answer of 3.58 times 10 to the negative 4th meters cubed. All right. Now, that's how I would actually run through that problem. However, I want to show you another way. So we're going to start out with the same top. And we're going to get to the same answer. However, instead of going directly from centimeters to meters like I can, I'm going to use the conversion factors on the back, left-hand side near the middle, that say length. And I'm going to go from centimeters to inches. So this is 1 inch has 2.54 centimeters. Now, that needs to happen 2 more times. Now I'm in inches cubed. So now I need to go from inches to, I can go directly to meters. So this is inch now on the bottom and meters up top. Well, meters is bigger, and in a meter are 39.37 inches. Now, if I do that 2 more times, I'll be in meters cubed. I'm running out of room here. So I'm going to go ahead and use my nifty tool. I'm going to group these. I'm actually going to shrink it down a little bit. Okay, to give me more room. That's inches. This is 39.37 inches. So now I have to actually put in some calculations. It's not just simple subtraction of exponents. So get out your calculator and let's see if it's close. And the answer that I get just double checking, is 3.58 times 10 to the negative 4th meters cubed. Is that the same answer? It sure is. However, look at all the additional steps I had to take. So the idea, and it happens through practice, is you want to try to take the most direct route as possible. Can you do it this way? Sure. But you're going to use up more time if you continuously take the longest path to these answers. All right. So that was multiple units in the form of the same one but squared or cubed. This is going to be multiple units in the fact that we have one in the numerator and one in the denominator. So we have to show all our conversion factors. Now, please make sure that when you're following, setting up these problems that have one in the numerator and one in the denominator, that you're following these steps to a T. So let's go and put it in scientific notation. Kilometer goes up top, and we're going to put 1 hour in the denominator. Notice how I put that unit in the denominator. If you don't do that, bad things will happen. So the first thing that we want to do is you pick whichever one you want to convert first. So if you want to convert kilometers first, do that. If you want to convert hours first, do that. We're going to start with kilometers. So kilometers is going to go down the bottom. Meters is going to go up top. So I can literally go directly to meters. Okay. Kilometers is bigger, and I will tell you that there is 1,000 meters in a kilometer. So right now we're in meters, which is what we want. I'm going to go ahead and change colors real quick. Blue looks good. Okay. That's where. There we go. Now we can do hours. This is where it gets a little tricky on this. Since kilometers went down to get canceled out, hours has to go up. So we're going to put hours on the bottom. And some of you may know how many seconds are in an hour, but I know all of us know how many minutes are in an hour. And then I know that we know how many seconds are in a minute. So the bigger one here is an hour. The bigger one here is a minute. There are 60 minutes in an hour, and there are 60 seconds in a minute. So you're going to get out your calculator, and I'm going to plug in 9.421. You can multiply that by 10 if you'd like, times 1,000. And then we're going to divide it by 60 and divide it by 60 again. I'm going to write it in scientific notation. Sig figs goes off of your original answer. That has 4, so I need 4 times 10, and that would be to the first, and that is meters per second. Okay. So that's about 26.2, 26.17 meters per second. It's pretty fast. So that is multiple units. What I would like for us to do is I'm going to let you guys work on this one. It is a little bit difficult. Notice how we are in the English system right here and the metric system right here. Go ahead and pause it and then start working on this. I'm going to count down from 5. After that, I will show you the work. 5, 4, 3, 2, and 1. All right, first we're going to put this in scientific notation up top. I'm going to go ahead and put this back on that. Times. Now, on this one, I'm going to go from seconds to minutes first, just to show you that you can do either one first. Minutes is 160 for seconds. The next one, we're going to go from feet. Now, if you look at the back of your periodic table, you will notice that we don't have a direct from feet to centimeters. So you have 2 different paths. You can go from feet to inches inches to meters, meters to centimeters, or you can just go from feet to inches, inches to centimeters. That's the way that I would like to go. So I'm going to put a 1 next to the foot, 12 next to inches, and then we need to go from inches to centimeters. On the back, it tells us it's 2.54 and 1. And just like that, seconds is gone. We have minutes. Feet is gone. Inches are gone, and we're left in centimeters. So you're going to take your calculator, go ahead and plug that in. And you should get 1.924 times 10 to the fourth. Okay. It was looking too much like a 9, so I had to get rid of that. 4, and that is centimeters per minute. And just like that, you guys have tried one of the harder problems that I could throw at you. Okay. Let's look at a couple other things. We have some relationships. So it's just like direct relationships. One goes up, the other goes down. Goes up, one goes down, the other goes down. So thinking back to density, as mass goes up and volume goes up, so does density. And then the other one would be an indirect relationship or an inverse. And this is like if one goes up, the other goes down. This could be like you guys, the more homework you have versus your happiness, the more homework you get, maybe the less happy you are. One goes up, the other goes down. And with direct relationship, it could be the number of friends you have and how social you are. All right. Hey, that was chapter 2, section 4. Go ahead and try those worksheets and let me know if you have any questions.